Microchips are advanced electronic devices comprising a dense network of microscopic semiconductors built in layers on a thin wafer of semiconducting material, usually silicon. These tiny circuits are normally hidden from view, but there are certain exceptions where we're allowed a peek inside at the surface layer of a microchip's silicon die. And what we're able to see when we do is truly remarkable. What I'll attempt to do in this video is to take you on a brief tour of the visible internal workings of a microchip and explain as best I can the parts I'm showing you and how they work. So here's an example of a chip. And here's a far more sensible one. This one's EEPROM or EROM flavour, which stands for Erasable Programmable Read-Only Memory. And these chips serve to provide an operational code or firmware to a system. It's designed to be programmed once in manufacture and can be erased only by shining an ultraviolet light onto the silicon through this quartz glass window. And you can see that that window, rather conveniently, allows us to very easily see inside and get a look at the surface layer of the silicon. So let's have a look at it under an optical microscope. At just 100 times magnification, there isn't all that much detail visible, but we can see the majority of the main parts. These two large, seemingly blank areas are called the memory blocks, and can contain billions of tiny transistors, which each store a bit of data. This particular chip is a 27C512 from ST Micro, which can store 512 kilobits of data, so will contain at least 512,000 of these transistors, each serving to store either a 1 or a 0 by switching on or off respectively. Upping the magnification a bit, you might just be able to make out a regular pattern of the transistors. This is around 800 times magnification, so you can get an idea of just how small these really are. I'd need well over double this to see any reasonable detail in the individual transistors. I could get it by switching in this third objective lens, but because the silicon is set deep inside the package, in order to focus on it, this lens would have to be so close that it would just obscure all the incoming light and we wouldn't be able to see a thing. As usual, nothing's perfect. Around the memory blocks we find the supporting circuitry. This is used to interface between the thousands of transistors in the memory blocks and the external circuitry away from the chip through only the 28 pins on this package. It'd be highly impractical to have one pin dedicated to each transistor. That would require over 500,000 pins on the package, which for obvious reasons can't be done. So this circuitry does something convoluted to connect all these transistors in such a way that they can all be accessed through these few pins. I'm not sure quite how this one does it. It probably has some form of addressing system, whereby it connects a small number of the transistors containing the required data to the output as and when they need to be accessed, based upon some form of inputted address. There's some sort of identification code there, M752. No idea what that's for, I can't find any data on it. Unfortunately, that's the closest we come to seeing any form of chip art on this one. Not very imaginative really. Further to the extremities of the silicon, we find the output buffer amplifiers, which interface the high output impedance of the silicon circuitry and the low input impedance of the external circuitry. This prevents the external circuitry from loading the silicon circuits and interfering with their operation. This is similar in concept to just a unity gain op-amp operating as a voltage follower. Off to the sides here we can see the bonding wires connecting the silicon with the pins on the package. There are 30 of them, presumably a couple are paired up for current carrying capability. Good alliteration there. Actually, that reminds me of another one of my videos with a lot of alliteration. Anyway, I've gone a bit off on a tangent there. Yep, there's a pair. And there's another. Those will probably be the VCC and ground. These wires are all made of silver, which is the best conductor of electricity, and it seems as though they've just been pressed onto the pads on the silicon die. I'm not sure whether it's actually resistance welded maybe, but somehow they've been affixed to make an electrical connection. There's nothing else in this package, it's just the die in the middle there, and the bonding wires which go off to the pins, so there's a lot of wasted space in these things. It's incredible to think that we can do all this really. This is only a small ROM device, this is nothing compared to modern microprocessors. And this is just the top layer that we can see. There's more going on underneath that we can't. It's very extensive, and it's amazing to see how much things have changed in electronics. Electronics with ICs has very little personality now. It's all hidden away and disposable. It's integrated. And it is convenient and robust, but it just lacks something that doing it all with individual components has, a certain finesse. If I need a single logic gate in a circuit, I'll still do it with a pair of transistors, just because I think it's nicer than plonking in an anonymous dip to do it all for you. It might be easier just to use a 4000 series logic gate. But my electronics work is very important to me, and sometimes I just prefer to do it myself, rather than use an off-the-shelf part that's been designed to do it all for me. That's not to say ICs are bad. They do their job very well, and I will use them where I need the convenience. But it's nice to still have a little control over some things. Now, I don't specialise in this area, so I can't guarantee that everything I know is exactly correct, and this has been a simplified overview at best. But if you know a bit about these devices, and you're sitting there thinking I'm spouting absolute nonsense, please do let me know in the comments. I can put annotations on to correct myself, I can add bits in, and it helps me learn too. So thank you for your time. I hope you've learnt something from this and not found it too tedious. If there's anything else you'd like to know, leave me a comment and I'll try my best to answer it. Thanks for watching, hopefully see you in the next one.